An arithmetic sequence is a sequence where the difference between successive terms is the same number. Here's an example of an arithmetic sequence: 2, 4, 6, 8. The difference between the successive terms is 2. And arithmetic sequences can be written out recursively as an is equal to an minus 1 plus d. An is any term, and it's saying that the next term is going to be the term before it plus whatever the difference is. That defines an arithmetic sequence. So something like this, if I wanted to know what an3 is, an minus 1 would be 4, and the difference is 2, so it would be 4 plus 2, which is equal to 6. And I can have arithmetic sequences in more familiar sequence formulas like this. This is an example of an arithmetic sequence because as n increases, it's only going to be increasing by 3 every time. Because this is a constant, so I don't have to worry about this. So the next term, it's going to be only 3 greater, and it'd be easy to show this. I can just plug it into this formula right here. In fact, that's probably the best thing to do. Since this is such an easy example, I could get something that's a little bit more complicated, and it might not be apparent right away if it is arithmetic, but normally it is. I mean, if it's just some constant value or some linear value like an n, then there's no way it can't be arithmetic. But here's an easy way just to show. So this is the formula: an is equal to an minus 1 plus d. So I just need to figure out what the difference is. Here it's obvious that it's 3, but if I wasn't sure. So I've got that part. Now I'm going to plug in an minus 1 is equal to 3n minus 1 plus 5. Multiply this out. 3n minus 3 plus 5, so plus 2. Now I can simply look at it from the perspective of the definition of an arithmetic sequence. An is equal to an minus 1 plus d. So I have an is equal to 3n plus 5, and an minus 1 is equal to 3n plus 2. So I just substitute them in. And then I just subtract. So these ends will cancel, and then positive 2 plus 5, so d is equal to 3. But of course that was easy to see just from the beginning, because the only thing that's going to be changing is the value of n, and when n increases by 1, that means the next term, the only difference is going to be whatever that increased n is, which in this case is 3. But that's how it would be. This is how the proper way to go about it would be if I weren't sure. And the last formula that I have on here is just to find the nth term of an arithmetic sequence. It should be pretty easy to get without it. I mean, most people would just be able to use common sense and figure it out. Since the difference is going to be the same number between each term, I basically just take my first term and then whatever number of terms beyond that first term. So if I want the third term again, I have my first term, and then I have 2 other additional terms that I just multiply by that difference, and then I add them together. So for 6, that I have 1, 2, n minus 2, so this would be for the third term. 3 minus 1 is 2. It's 2 times, and the difference is 2. This is 4, so this is equal to 6 again. So that's a pretty simple formula to understand.